Welcome back. This lesson covers object-oriented programming and is focusing on advanced level concepts as part of the Python Advanced series. It is mostly relevant to A-level Paper 4 exam. However, if you're interested in object-oriented programming and would like to develop your understanding of Python a bit further, then this lesson is for you as well. We're now into the business end of the series of lessons, and an understanding of object-oriented programming is crucial if you want to deal with things like linked lists and binary trees and recursion at times. We're going to be looking at the different concepts involved like encapsulation, inheritance, containment, and how you can implement those in Python. So let's begin. So what exactly is object-oriented programming? Well, it's a programming paradigm which is based on the concept of objects and classes. So what's a class? Well, a class is basically a blueprint or a template, and an object is an instance or occurrence of that particular template. All the data and operations that can apply to a single entity are part of an object, but these are defined in the class itself. Each object holds specific information about a particular entity. For example, a car class can be created, which contains the attributes of, say, name and model, and an object called new car can then be created based on that class, which will actually have the data values, for example, Tesla and Cybertruck. Now you can see an example of how that would look like. New car equals car is the class, and then you have round brackets, Tesla and Cybertruck as strings. You have to understand terminology like attributes and methods. What are attributes? Well, basically when you define a class, which is a user-defined data type because it doesn't exist before you define it, attributes are the variables used in a class. Objects normally don't just have attributes, they also have actions, and these actions are basically functions, and these are known as methods. So attributes are the variables and methods are the functions that you can apply on those variables. Now on screen you see the definition of the car class as we were discussing in the last section. It contains a function which is called initializations, and that's always def underscore init. Now if you have two underscores, that's private. If you have one underscore, that's public. We'll look at that in a moment as well. But what that initialization one does is it sets up the variables that need to be used when you create an object. So in this case, self refers to the class, name and model are the two inputs that will come in, and self.name will be the name and self.model will be the model. And this is the normal convention. So basically we set the name and model when we initialize an object of the class car. Now we're creating another method. This one is called display name and it refers to self. Why do we put self in? Self refers to the class itself. And this method will return self.name, the name variable, back to the main program. So once we define this class, this car object, and the two attributes name and model, and these are always defined in the initialization function. This is also known as the constructor. And the second is the method display name, which will return the name back to the main program. Now I'm going to create an object, which is new car, and that's going to use the car class, and it's going to have two values that will go into it, Tesla and Cybertruck. The first one is going to be name, the second one is going to be model, because that's what I defined in the initialization function. Temp is going to be new car dot display name. Now our new car already has a name, already has a model, and what if I want to find that out in the future? I simply say temp is equal to new car dot display name, and that method will return Tesla back to the main program and put it in a variable called temp, which I can then print out. So do pause the video and study this in a bit of depth if you are new to classes and methods. So summarizing the difference between a class and an object is a class is a template and an object is an instance or occurrence of that template. Putting the data or attributes and methods together as a single unit is called encapsulation. That's why classes encapsulate both data and methods. Now the difference between a class and a record data type would be that a record data type does not contain any methods, just the attributes. Now we can create that as a form of a class as well, but to have true encapsulation, we need to ensure that we have both attributes and methods in the same class. The object inherits these methods or these functions of the parent class, and this is called inheritance. A class can also be a blueprint for other classes. So I can define a class called vehicle, and I can then use that in a class called car. So the class car inherits the attributes and functions from the vehicle class. Now we touched on public and private attributes. This is very important. You need to make sure you understand how these work, because normally in an exam you might get a mark or two for saying declare the variables or declare the attributes to be private. So how do we do that? The attributes that have to be declared as private can only be accessed inside the class. The methods which are usually declared as public can be accessed outside the class. And you do that by 2 underscores for private and 1 underscore for public. Of course, in Python, you might need to write a comment statement. When you're declaring attributes, you will need to say declare private or private name colon string, something like that. Now, we also mentioned a constructor. What is a constructor? And this is also very important because sometimes in an exam they say use a constructor to define a class or create a class using a constructor, and you're like, what's a constructor? Well, a constructor is basically the initialization function. These are functions which are used to initialize the attributes and the properties of a class. And basically it's that def underscore init underscore brackets self part. Now the 2 underscores here indicate this is private. So we're creating a private constructor. If we wanted to create a public constructor, you could do that with a single underscore. But remember, this is basic object-oriented programming terminology, and this is the way we implement it in Python. Okay, let's try practice question 1. Create a class called player. It should have 2 private attributes called name and age. It should also have 1 method called display name, just like we had in the car class. You should use the class to create 2 objects, player 1 and player 2, with the following data: Ghost 21 and Ninja 19. Finally, the names of the objects should be output by the program. So pause the video, have a go, and then continue to check a possible solution. Okay, hopefully you've got something like this. For creating the class, you've got a class called player, and then you've got 2 comment statements. If you forgot about them, please remember you've got to do that. Private name, which is a string, private age, which is an integer, and the 2 underscores mean private. So I'm going to create my constructor, def 2 underscores init, 2 underscores self comma name comma age colon. Self.name is equal to the name variable. Self.age is going to be the age variable or parameter that's passed later on. And then I'm going to create a method called display name, which is going to refer to self, and it's going to return self.name. So whatever name that's in that particular object is going to be returned back. So that takes care of our class, and that's probably going to be 4 or 5 marks in an exam. What about creating objects? Well, at the beginning of the program, I should declare temp1, temp2 as strings because those are the variables I'm going to be using, but I don't need to declare player1, player2 because those are going to be objects. Player1 is basically of class player type. Okay, so if you wanted to declare it for some reason, you would have to say declare player1, comma player2, colon player, but you're never asked to do that in an exam. Okay, so for player1, we're going to call the player class, and we're going to pass the 2 data values Ghost and 21. Ghost is a string, 21 is an integer. Player 2 is going to be the same. This time we're going to pass Ninja and 19. Python is going to store all of this in memory, and it's going to make all the links for you, so you don't need to worry about anything. When we want to use a particular method in that class, we're simply going to create a variable, and we're going to say temp1 is equal to player1 dot display name 2 round brackets, and that's going to take the name Ghost and store it in temp1, and we can print it out. And similarly, we can do temp2, which is going to be focused on player 2's name. So player2.displayName is going to call the method in the class, and it's going to return the name and store it in temp2, and then we can print temp2 out. And that's how we create objects, and that's how we can use methods to get data back once we've created an object based on a class. So here perhaps you can see the benefits of using object-oriented programming, because once we use the same class and the same code over and over again, we can create many objects. So objects provide the benefit of modularity and information hiding, and classes provide the benefit of reusability, and that makes programming much more effective. Nobody knows what's going on in an object because you're not showing everything to them, because the data is hidden in memory, and the class contains the blueprint, and it could be reused again and again and again. Okay, let's move on to practice question 2. We're going to use the following information to create a class. We've got description, string, width, integer, height, integer, frame color is a string. We're going to create the constructor. What's that? Hopefully you remember it's the 2 underscore init if it's private, or 1 underscore init if it's public. We're going to have some methods called get description, get height, get width, get color, and set description. These are called getters and setters. Getters return information back to the main program. So all you need to do with those is just simply say return self dot something. And setters assign a data value to a particular attribute, and they are kind of like your constructor. Sometimes you might want to change the value of an attribute which is in a constructor, and that's where the setter comes into play. So getters return something to the main program. Setters change an existing value in an object. So make sure you remember the terminology getters and setters. Okay, pause the video and have a go at coding this. On screen you see a possible solution to question 2. Hopefully you declared your attributes as private. You can do it inside the class, you can do it outside the class. As long as you got it there, you'll get the mark for it. So we've got class picture, and we've got the constructor, which is def 2 underscores init 2 underscores brackets, and then in the brackets we've got self, which refers to itself, and the 4 parameters descriptions, width, height, and frame color. And then we're going to set self.description equal to the description parameter, self.width is equal to the width. Now here, if the width was coming in as a string, you can change it to int width, but you could also do it outside when you assign values to a particular object. Self.weight is equal to weight, self.frame color is equal to frame color. We then have our methods, get description, which returns self.description, get height, which returns self.height, get width, which returns self.width, and get color, which returns self.frame color. And then finally we have the setter, and we implement it by simply saying this is the set description, which is going to be referring to self, and it's also going to have a new value that comes in from the outside. When we call this, self.description is equal to new. So we're overwriting the existing description with this new version of it. And all of these are part of the class itself, which you can see with the indentation. If you couldn't do this, pause and code it. When you run it, you're not going to see anything because all we're doing is defining a class here. So as long as you coded it right, it'll work when you do call it. Okay, let's look at practice question 3. Here you're going to create a new program, and in the program you're going to declare the class treasure chest. You're not writing any methods here. The attributes are all private. If you're using Python programming language, include attribute declarations using comments. Now this is an exam question. So we're only implementing the first top part, which is the 3 attributes question, answer, and points in the constructor class. So pause the video and then code this and check your answer. Now do remember, you might be tempted to code the getters as well, but you don't need to at this point in time. You've got to follow what the exam board says, and they want it done step by step. So that's what we do. On screen you see a possible solution. We've got the class treasure chest. We've got question as a private string, answer and points as private integer. We're going to define the constructor with 2 underscores because they want to keep it private. It's going to have those 3 parameters, question, answer, points, and it's going to refer to self.question, and self.question is going to be question, self.answer is going to be answer, self.points is going to be points. And that's all we need to do. And that's going to give you 1 mark for defining the class and the attributes, perhaps 1 mark for the constructor, 1 mark for assigning values. So possibly 3 to 4 marks here really. Okay, let's move on to the next part. The main program repeats each question until the user inputs the correct answer. The number of points awarded depends on the number of attempts before the user gives the correct answer. So the first part of C, the class treasure chest, has a method getQuestion that returns the question. Write this method getQuestion. So all you need to do is write the getQuestion method. So this getter will just simply return the question back, and that's all you need to do. Now this is going to be worth 2 marks. Now the second part simply says the class treasure chest has a method checkAnswer that takes the user's answer as a parameter and returns true if the answer is correct and false if it's not correct. So because they're both returning something, they're quite clearly getters. So you need to create get methods in your class, and they will return something back to the main program. If you're still not sure about what to do, just rewind the video a bit so you could see practice question 3, which had a bit more description to these methods, and then pause the video and have a go. I don't think these are too tricky to implement. Knowing what you know by now, this should be a breeze. Your get question method will return the question back to the main program, and your check answer would refer to self and take a new parameter called answer. And if answer was equal to self.answer, then it returns true, else false. So it's basically a comparison using an if statement, and it returns true or false back to the main program. Now do remember the indentation here. Both of these methods are part of the original class. Don't code them as separate functions. They have to be in the class, otherwise your program won't work. So this will give you access to 5 easy marks, 2 marks for the getter, 1 for defining it, 1 for returning self.question, and 3 marks for the next one, 1 for defining it, 1 for the selection, and 1 for the returns. Okay, let's move on to practice question 5, which continues on the previous question. The class treasure chest has a method getPoints that takes the number of attempts as a parameter. So you're going to put in the number of attempts, and if the number of attempts is 1, it returns the value of the points. If the number of attempts is 2, it returns the integer value of the points divided by 2, for example div2. If the numbers of attempts is 3 or 4, it returns the integer value of points divided by 4, div4. If the number of attempts is not 1 or 2 or 3 or 4, it returns 0. For example, a question which is worth 100 points and the user took 2 attempts to give the correct answer, the user is awarded 50 points, 100 div 2. Now it might look complex and wordy, but all it is a basic getter method. So all we're doing is creating a function called getPoints, which refers to self and has an additional parameter which is the number of attempts, and if the number of attempts equals 1, return this, else if number of attempts equals 2, return self.points div2, and so on. So pause the video and have a go at coding this one, and then continue to check a possible solution. Hopefully you've got something like this going. You define getPoints with self and attempts. If attempts equals 1, then you return self.points. Elif attempts equals 2, you return the integer of self.points divided by 2, or you simply do self.points 2/2, which is div. Elif attempts equals 3 or attempts equals 4, we return self.points 2/4 or integer of self.points/4, whichever way you've implemented div. Else we return 0. Now you can see here you're going to get quite a number of marks, possibly about 5 or 6 marks. 1 for the definition of the function, 1 for attempts 1, returning the point, 1 for div, 1 for or, and 1 for returning 0. So possibly 5 or 6 marks in this set of code. Very easy marks to get because all it is a selection, div, and your understanding of how to use methods, especially getter methods. Okay, let's move on to inheritance. What is inheritance all about? Now we've said that objects inherit methods from classes, and similarly classes can inherit methods from other classes or parent classes. What does it actually mean? Now if you look across here, we've got a part-time employee which has attributes name, age, and hourly rate, and it has methods getName and daily wage. You also got a full-time employee which has name, age, monthly rate now, that's the only difference, and has methods getName, but another new method called yearly salary. Now we can code these as 2 separate classes, which is fine, but you can quite clearly see both of these are employees. They share similarities. There is duplication here. So what do we do in this particular case, where there are some similarities, but there are some differences as well? That's where inheritance comes to play. So what is meant by inheritance? Well, the derived class can use the properties from the parent class without redeclaring them. The derived class can use methods from the parent class without redeclaring them as well. So you can see where this is going. We're going to have probably a superclass or a parent class called employee, and we're going to then have subclasses part-time employee and full-time employee, which are based on the parent class. The derived classes can extend or change the properties from the parent class and the methods as well. So you can see where this is, the similarities will keep, and we'll just change the methods where they're different. So how do we implement something so complex in Python? Now lucky for you, Python has a built-in function called super. Super provides a way to access methods and attributes of a superclass from a subclass. Now it's used to call the implementation of a method that is defined in that superclass, which has been overridden in a subclass. Now why should you use super? Well, if you want to extend the methods used in a parent class in a subclass, then you should use the super method. If you look at the example on the right hand side of the screen, we've got a parent class called vehicle, which has a method called drive, which just simply prints out driving the vehicle. That's all it does. We've got a class which is called car, which uses the vehicle class, and then it redefines the drive method by first saying take super's drive method, super brackets dot drive. So we're referring to the vehicle class's drive method, and then print driving the car. So it's going to print first driving the vehicle, driving the car. So you're modifying the original drive function for a subclass. So if we create an instance of the car class where we say my underscore car is equal to car, and then we call the my underscore car dot drive function, it's going to print driving the vehicle, driving the car, both lines. If you created a new instance where you said my underscore vehicle is equal to vehicle, which is the parent class, and then do my underscore vehicle dot drive, it's just going to print driving the vehicle. So quite clearly we've modified the method drive to print out or do something unique for the subclass. Now this is what we'll use to solve our problem with our employees. To use inheritance in Python, you will first need to define a super or a parent class. Then you're going to use the parent classes and the super classes methods. Then you're going to use the parent classes method in the child class. The name has to be the same. And then you're going to define any further methods that are only used for the child class. It can still use the parent classes methods as well, plus its own methods. So how would it look like? Well, we've got our class called employee, and it's going to have name and age as private. And then we're going to have our constructor in there, which is going to simply say name is going to be name P in this case, age is going to be HP because it's parent. That's what the P is for. We're then going to have a method called getName, which returns self.name. Now you don't really need to put those two underscores in the return, but if you want it to be very precise, that's how you refer to private attributes everywhere in a class. Now that was the common function, because getName is common to both part-time employee and full-time employee. Then in the part-time and the full-time employee, we're going to have our unique attributes, hourly rate for part-time and monthly rate for full-time. We're going to have our constructors again, but this time the constructors are going to use the super's constructor first and then refer to its own unique value. So super.init, again private, name and age is present in both part-time and full-time employees constructors. And then we refer to self.hourly rate or self.monthly rate. The daily wage and the yearly salary is also bespoke or unique to each part-time and full-time classes respectively. So we're going to define them in each one. So for the part-time class, we're going to have a daily wage method, which is going to have hours worked, and then it's going to use that for a calculation and return it back. And similarly for the yearly salary in the full-time employee, we're going to have a method which works out using the monthly rate, what the salary is, and it then returns it. So that's how the structure would be like. Now both of these subclasses, part-time employee and full-time employee, can refer to getName. So we don't need to define that one because that's common to both of them. When you want to refer to it, you can just simply say full-time employee.getName. That should work because full-time class has employee in the brackets as the parent class, and same goes for part-time class. It has employee as the parent class in brackets when we define it at the beginning, and that relates both of these to the employee parent class. So the class diagram looks a bit like this. Now what is a class diagram? It's a very easy way for us to represent relationships between parents and child classes. So sometimes you're asked to draw these out in an exam, so just make sure you know this. I think we did cover this in theory as well, but just in case you've forgotten about this, the employee class is linked to part-time employee and full-time employee. And normally the convention is to denote the arrow that way, that the employee is the parent class. So again, it's pretty straightforward. Okay, the best way to learn about anything is to practice it. So try practice question 6. A sports club stores data about its members. A program is to be written using object-oriented programming language. A member class is designed. It has two subclasses, full member and junior member. Draw an inheritance diagram for these classes. Now, so at home, try to draw a class diagram for this. 3 easy marks to get. Pause the video, and when you're ready with your sketch, continue on to see if you got the right answer. Okay, you should have something like this. Member is your parent or superclass. Full member and junior member are part of that class. Now, you could have one arrow going to both, or you could have both arrows separately. That doesn't matter as long as both of those subclasses are part of the member class. The member class is the parent. The arrow always goes that way, towards the parent class. Okay, let's try coding this now. Practice question 7 focuses on the design of the member class, which consists of the following attributes or properties: member name, member ID, subscription paid, and the methods in this class are set member name, set member ID, and set subscription paid. So 3 setters here. Write program code for the class definition of the superclass member. So pause the video and have a go. You should know how to do a class, you should know how to initialize a constructor, and you should also know how to do setter methods. Now on screen you see a possible solution. You've got the member class, which has a few private variables. We define the constructor. We said member name is equal to empty, member ID is equal to empty, subscription paid is equal to false because it's a Boolean. We then set the member name to member name, set the member ID to member ID, set the subscription paid to subscription paid. These are parameters that the user will enter. Now, in this case, you will notice that in the constructor, we haven't defined the parameters because the exam board asked us to do it this way. When they say you've got to use setters, that basically means you're using setters to set the values. Could you have done def init self member name, member ID, subscription paid, self.membername equals member name, self.member ID equals member ID, self.subscription paid equals subscription paid? You could have done it that way as well. Chances are you probably still get the marks, but this would be the correct way if you're given setters and the constructor in the same question. This would be the right way to do it. You want to keep them empty initially, just placeholders, and then use the setters to set the values of something like this. Hopefully that makes sense, and hopefully you got it. If you haven't, pause the video, code this, and then continue on to practice question 8. Here you need to add a date of birth property to the junior member class. So write program code for the class definition for the subclass junior member. So we're now creating the subclass. So our good old friend super might come in handy here. Pause the video, have a go, and then continue on to check possible solution. So the class junior member uses member as the parent class, and that's in the brackets at the beginning. In comments, you can have date of birth as a string. That's the variable we use later on because that's the only new one in this one. We have a constructor which uses the super.2_init. That's going to be the constructor of the member class, and then it adds self.dateofbirth and keeps it as an empty string. And then we have set date of birth, which is going to just focus on the date of birth, which is going to be given by the user, and set it for the junior member class. Remember, it's not required in the member, but only for the junior member. The set member name is going to be the same as the super from the previous one. Set member name is equal to member name, and the set member ID is going to modify super set member ID to use member ID, and set subscription is going to be the same. And why do we have to do these this way? Why do we have to have these additional ones? Because if we had defined the values in the member class, then we wouldn't need to do this in this one. Unfortunately, in this particular question, the exam board set it out this way, so we had to rewrite these for the subclass. Technically, if you had set them up in the member class, you wouldn't need to do that here. Okay, that's enough about inheritance. Let's move on to containment. Containment is a fundamental concept in object-oriented programming, and that refers to the ability to include one object inside another. So it's like the inverse of inheritance. Whereas inheritance, you inherit something from the parent class. In this one, a big class or a superclass can contain subclasses. So it can refer to a subclass's methods, and it goes the other way. I'm going to go through this with an example so you can understand it better. A vending machine allows users to insert coins to purchase an item. The user then enters the code for the item they would like the machine to dispense or give out. Now, we use vending machines, we know how it works. The user enters the code 02, and if the code is valid, but the user hasn't inserted enough money for the item chosen, the machine waits for more coins to be inserted, and the user then has to re-enter the code. The user can press cancel anytime to return the money inserted into the machine. So we know that if you put a pound in, type 02, if the item was £2, it's not going to do anything until I insert a pound again, and then I have £2 in the machine, and then I have to type 02 again. Or if I don't have enough money, I just press cancel and it returns the money back. Now, the vending machine is part of a program that is written using object-oriented programming. The vending machine makes use of two classes that are described in the following tables. The attributes are all declared as private. The first one is the food item, which is going to be name, code, cost, and it's going to have its own constructor, which we have to put values into it. And then you got get code, get cost, get name. So again, this is pretty straightforward. And then the second one is going to have the vending machine. The vending machine is going to have items, which is going to be an array of food items. So you can see where this is going. We're going to create an array in the parent class, which refers to the other subclass called food items. And it's going to have 4 items in this particular case, 0 to 3. And it's going to have money in the vending machine class. So they could only choose out of these 4 food items, which are going to be based on the other subclass. So in a way, you might say, well, the food item, is that becoming the parent of containment? No, it's not. It's being part of containment. And the way we contain something is by creating an array of that particular class inside a superclass. And then we've got our methods: constructor, insert money, check validity, and get item name. So you need to write now the program code to declare the class vending machine. You're only required to write program code for attribute declarations and the constructor. So that's the first part. If you're writing in Python, include attribute declarations in comments and use your programming language's constructor method. So that is the first task. This is not a practice question. You can have a go at it if you so want to, but I will explain how it works step by step, and then we'll do a practice question. So the class vending machines, we're going to define it as normal, but it's going to have 2 comment statements. First, for that array, the array has to have 4 items. So it's items array 0 to 3 of food items, which is going to be a class we write later on perhaps. And the second one is going to be money in, which is going to be real. And we're going to have our constructor, which is going to be self, item 1, item 2, item 3, item 4, which is going to come out from another class. And then self.items is equal to array. And then self items.append item 1, item 2, item 3, item 4 into that array. This is how we add to an array in a constructor. And then we're going to define money in. We set it to 0 because the money hasn't been put in yet. Pause the video, study this if you're not sure how this works. The key bit here is to focus on how we set the items array, which is just basically an array. So 2 square brackets, that's all you need, and that's the beauty of Python. It simplifies things, and we just simply append or to add things to it using a built-in function. Okay, let's move on with the next part. The method check valid takes the food item code as a parameter. It checks the code against the element in items and returns -1 if the code is not valid, -2 if the code is valid but the money in is less than the cost of the item, the index of the item if the code is valid and the money in is greater than or equal to the cost of the item. Write the program code for the method check valid. Now in this you will need to use a selection. We define our function check valid, and that takes in a parameter called code. We then do a loop for x or index in range 4 or start with 0 and loop 4 times, whichever way you want to do that. We're then going to have a nested if statement in there. You could probably use a Boolean operator here, but nested probably would be better. So if self dot items bracket x, this is the array, dot get code equals the code that the user has entered, then we're going to check if items array x's cost is less than or equal to the money in, then we return x, which is the index back. Else we return -2 because it's not going to meet either of those. Or outside the loop, we're going to return -1 because we checked all 4 items in the array and the code didn't match, therefore it's invalid, which was -1. So this is just a bit of logic. This is just one way of doing it. There are multiple ways of doing this. The best way to do this is to test your code out and try coding this after watching this segment and then see how it works. Okay, finally, we've got 4 objects of type food item that are declared with the identifiers chocolate, sweets, sandwich, and apple. Write program code to declare an instance of vending machine with the identifier machine1 and the objects chocolate, sweets, sandwich, and apple. And this is pretty straightforward. All you need to simply do is write machine1 which is going to use the vending machines class, and it's going to have 4 items: chocolate, sweets, sandwich, and apple, and that's going to be put into the class. So 2 easy marks here. Hopefully all of that makes sense. You might want to rewind it and watch it a couple of times if it doesn't. Containment can be tricky. I know that my students can struggle with it, but then the best way to get over is to practice again, ask questions. So use the comments if you're not sure about something here. Okay, practice question 9. Let's see if we can implement a solution like this. Ijaz is creating a program that will allow the user to create quizzes. He is using object-oriented programming. There are 2 classes, question class and quiz class. The class attributes and methods are in the tables. All attributes are declared as private. Write program code to define the class quiz class. You're only required to write code for the attribute declarations and constructor. If you're writing in Python, include attribute declarations using comments. So we're now going to be focusing on the quiz class, which is on the right hand side. But let's study both of them together. The question class has questions, answer, and difficulty. These are the variables it's going to use in its constructor. The methods are obviously the constructor itself, the get question, which is going to return the question, and the get answer, which is going to return the answer. The quiz class, on the other hand, is going to be the one that contains the question class, and it's going to have an array which will have 20 questions of question class, and it will have a number of questions which is going to be the integer. Then it has its own constructor. It's got add question, which allows you to add questions to the array, so the append function might need to be used in here. Then it's got get question, which returns the next question, and check answer, which checks the answer and returns true if it is correct. So it's pretty straightforward to look at the question and work out how to code all of these. So take your time, pause the video, see if you can write the answer to the constructor for the quiz class, and then continue. Remember, we're just doing the right-hand side quiz class, we're not doing the question class here. Okay, you should have something like this. You've declared the quiz class. This is obviously the parent class. It's got private questions, which is an array of 20 of question class, and private number of questions, which is an integer form. You then define the constructor, which is going to set the number of questions to 0, which is the integer. Then it's going to have the questions array. We're going to do a loop which runs for 20 times, call question class, and in question class you had 3 values. The first 2 were string and the third were integer. So we're just going to have an empty space, and 0 20 times in this array because we haven't set anything up yet. Hopefully that made sense. If not, go through the entire question set and then you can see how everything is interrelated if you can't make the connection right now. The second part simply says the quiz class method add question takes a question object as a parameter and stores it in the next available location in the array. It returns true if it's successfully stored and false otherwise. Write program code for the method add question. Okay, so pause the video. Maybe you might want to rewind a bit just to see the original descriptions and then code this particular method. Okay, the method should be pretty straightforward. You add question, and in this one you are going to have the question object which comes across from outside. If self.number of questions is less than 20, then you check if the array is already full. You don't want to add anything to it. Then you simply say if self.questions, that's the array, self.number of questions equals question object, then self.number of questions is equal to questions plus 1, and you increment it. So all you're doing is simply adding this new question object into the array and then incrementing the number of questions because you've just added 1. Remember, we set number of questions to 0. So every time we add a question, we increment that counter. And we return true that the question was successfully added to the array. Else, we return false because it wasn't added, because the number of questions was greater than 20, so we can't add it. So again, pretty straightforward, just a bit of logic. Let's move on to practice question 11. The first quiz is created with the identifier first quiz. The first question in this quiz is what is 100 divided by 5? The answer is 20 and the difficulty level is 1. Write program code to declare an instance of quiz class with the identifier first quiz. Declare an instance of question class with the identifier question 1. Add question 1 to the array in first quiz using add question. Now we've already done these 3 parts, so all you're doing here is simply creating objects or instances of those classes with the data value. So pause the video and have a go. So this part is pretty straightforward. First quiz is equal to quiz class, question 1 is equal to question class, and then you have your 3 pieces of data in there. And then finally, you're going to add the question to first quiz and all you need to do is call the method firstquiz.addQuestion question1. So this question 1 is added to first quiz. Okay, that was a very long lesson. Hopefully you've got a bit of a better understanding of object-oriented programming and how Python implements it through this video. Of course, you're not going to be an expert overnight, so you need to do a lot of practice with this, but perhaps this helps in developing your understanding of attributes and methods and the concepts of encapsulation and inheritance. You should also understand how to create inheritance or class diagrams, understand terminology like what is meant by a constructor, and you should be able to create a class using a constructor. Understand the difference between private and public attributes and methods, create methods in a class, create instances of a particular class, and call methods from the main program and assign data to it. You should also be able to use the super function for inheritance purposes, and you should also understand how containment is implemented in Python. Now, it is a big lesson, so my suggestion is that after you watched it once, maybe try some of the questions and keep working on this, perhaps over the period of a week, till you secure your understanding of object-oriented programming. It is an advanced concept. We don't teach it early on for a particular reason, because you need to be very comfortable with your understanding of basics like loops and selection to access some of the high-level concepts that are part of object-oriented programming. Of course, if you do have any questions, please write them down in the comments, and I'll see you in the next one.